if this is a 9, if this is a 8 right here, if this is a 10, your 9 should be right here, right? How so? Well, because from 0 to 2, your increment is 2. So each individual block should be 0.2. So 8.2, 8.4, 8.6, 8.8, and then 9.0. Then 9.2, 9.4, 9.6, 9.8, which is our data point, and then right here will be 9.8. So go all the way up, all right, and then perpendicular.
For plotting the graph and the data points, you will need a 15-inch ruler and a pencil. Mark each data point with a very small, solid circle.
Follow the line, it's being provided, so make your graph clean, all right? And then next one, 27.4, pass 27, but below 28, all right? So now let's see where that is located. This is the 20.00, this is a 30.00. So 21, 22, 23, 24, 25, 6, 7. Past 20, this is the 27.00. This one's the 28.00. So we'll be somewhere right here, below 5. All right, so 27, that's right. Yeah, right here. All right, so by using this third one, it's a 6.4, all right? So make sure you understand it's a 6.4, 6, it's here, 8, it's here, then 7, it's right here. All right, 7.0. So 6.2, 6.4, it's the second one, not 1, 2, 3, 4. That will be 6.8. All right, so that's 6.4. So you're located where 6.4 is, and go all the way up, and then you will have that. And then the next one, 18.03. It's not 18.3, it's 18.03. So 10 is here, 18 is here, and then so just a little bit 18. All right, next one, 4.7. All right, this one it's a little bit trickier. Here it's a 4.0, here it's a 5.0. All right, now 4.2, 4.4, 4.6, 4.8. So it is between 4.6 and 4.8. So in between, all right? Make sure you understand it. You go like so. So it's a 4. This is a 5, 4.7, and then go all the way up somewhere there. All right. 13.09, it's not the 13.9, so it's not even 13.01 yet. So here it's a 13, excuse me, here it's a 10.00, here it's a 20.00, and so 11, 12, 13, it's right here. And then, so now you have a 13, then you're going to right here, like that. All right, and the last piece of data, it's a 2.4. Make sure you understand it's a 2.2, 2.4, it's right here. And then last piece of data, 6.75. And then here it's a 5, and then 6. It's right here. All right, finally you have all the pieces of light. And then don't forget, ladies and gentlemen, I work very hard. I generate 40.00 and then 4.0. So 40 is right here, and the 4 is right there. So this is my data. All right? All right, very good. Now, your page 19 tells you need a number 1, generate one straight line. Number 2, include as many data points as possible. So now, what would you do? If you include all the data points all together, and then you have to generate a line like so. But if you have reviewed your page 18, you will know, you are told, if a data point is very obviously not a part of a data population, you should not include it. But you cannot arbitrarily eliminate it. You must keep it, but indicate it's a stray point.
The stray point is indicated with an asterisk sign, and each data set can have only one stray point. While drawing the straight line or slope of the graph, use the best straight and reliable line. Always check if there is a chance for the y-intercept to be 0.
Now you have 1, 2, 3, 4, 5 data points all together on this line, right? This is so-called 0.00 point. It's what we call the origin of the graph. Based on the information you have just obtained, answer the question, what is the relationship between the two variables? It means the mass and the volume. One is from your page 18. One is so-called linear. Second, it's directly proportional. And they both have exactly the same general mathematical expression, except our directly proportional, the b is 0. What does b equals 0 mean? That means when x is 0, your y is also a 0. And then that makes the relationship a so-called directly proportional. So now examine our data. When volume is 0 and our mass is also 0. All right, right here. So it is a directly proportional. And b, you are asked, determine the volume of a y-intercept. All right, y-intercept. Well, our y-intercept, in other words, it means your line intercept at y. Where did this line intercepted at y? At b equals 0. So simply say b equals 0. Yes or no? Here it's you will get a 1 point or you will lose 1 point. Examine your y. Your y here have a 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 2 digits after the decimal point. 0.000000. It's correct. But you still haven't had your total points just yet. A number without a unit is unusable. All right, so must include unit. Now you have all the points. All right, now you have all the points. And C, page 19 tells you that, and then page 20 explain and demonstrate how you should do it. Once, when your line is being generated, all your data points now useless. You cannot reuse all the data points anymore because you can see not every single one is exactly on your line, all right? A little bit up, a little bit below, so on and so forth. I will pick up 12, and then I will pick up 2. Why do we want to pick up 12 and then 2? Number one, those 2 volumes have not been used because you see example, it's not being used. So you can use it. But why 12 and then 2.0? Well, easier for us to process. That's number one because they're whole numbers. Number 2, they're far apart from each other, which your page 19 tells you that's how you should pick up your 2 data points from the graph in order to avoid bias. All right? In other words, you should not pick up 2 and 4 or 6 and 8 just to represent this part. You should pick up 2 pieces of data far apart to represent the entire graph.
The 2 data points for the determination of the slope, commonly known as slope points, are indicated farthest from each other on the slope itself as small and hollow squares. The x and y coordinates of these slope points are carefully indicated on the graph.
The x, now it's picked. So your y must be the one corresponding to the x. Your y must be corresponding to the x, all right? My y, it's a smaller one. It's a 5.50, and my y2 is and 29.34 all right, that will be it. And so that's it. So now you have 1, it's right here, and then 2, it's right here, right? And they use the mass expression. Your slope, it's y2 subtract y1 and x2 x1. All right, make sure it's a y on the top, x on the bottom.